Okay, so my name is Mateusz Stefańczyk. You can find me on LinkedIn and Twitter, and on daily basis, I work in House of Angular as Angular team leader. In House of Angular, we, as name suggests, specialize in Angular development. We provide ready-to-operate teams, but also we have a bunch of services like code audits. And if you struggle with your existing solution or would like to start the new one right now, don't hesitate to contact with us. Also, you just love Angular. Due to that, we support a lot of open source projects like NGRX, NX, and we also running our own community, which is called Angular Love. And Angular Love is the blog. Initially, it was the blog for all Angular lovers. Right now, we are also organizing the meetups. So follow us on social media to just get informed whenever we have some kind of the stream and activities that also might help you grow. We recently rewrite our blog. It was on the WordPress. Right now it's fully based on the latest Angular. It's also open source, so you can just take a look into the code, how it's done, how we utilize the latest features like SSR, signals, and get some inspirations, but also contribute and provide us with feedback when you feel that something can be done better. So, as I said, I will talk about the Angular architecture using signals, but we'll take a look at the architecture as some kind of the design decisions that impact the entire application lifecycle. And here we will just see how the decision to change the reactive primitive to signal just change the framework itself and way we work with it. So we will start with saying what is the signal. I know it was said a few times today, but we'll repeat and provide you with the types of the signals. Then we will see how it affects change detection, how it simplifies the components, and finally, how it's going to evolve the way that we are just managing the state in our application. So in simple words, as it is set in the documentation, signal is the wrapper around the value that notify interested consumers whenever that value change. So there is simply a relation that whenever we read the value from the signal, we just became its consumer. Signal track it consumers, and whenever it's changed, it informs all of the consumers, hello, I have changed, you need to update my value. That's how it simply works under the hood. And we can distinguish writable signals, computed signals, effects, and there are two new types of the signal-based primitives, linked signal and resource, which will be with us within probably 11 days, if I count properly, with release of Angular 19. So the most basic one is just writable signal. We define it using the signal function. It needs to get the initial value. We can make it as read-only, and we can consume signal by reading it. And we can read it like invoking the get in the template, for example. And what is right now very important, even in this small piece of the code, that this template right now gets registered as a consumer of the signal. We can update this writable signal using the update function or just the set. Another type of the signal is computed, and computed itself don't contain value. This value is derived from the other signals, and this computation being triggered when we read it for the first time. So if we will not read this signal as on this example, it will not compute, never. But if it will compute whenever count change, and it will multiply the value of count by 2. Another type of the signal are effects, and effects itself don't return the value, but similarly, they are just notified whenever the signals they depends on change. And what is important in terms of the effects is that they need to be initialized in scope of the injection context. So by assigning the value like I'm doing here using the logging effect, or in scope of the constructor. If we want to do it in the lazy way, we need to provide the injector to the effect by ourselves. And as you see in these examples, I mostly use it to console log something. And in the community and overall, there was said like we maybe should not use effects for the purpose they are intended to. Because for what we mostly have been using effects as a developers is to synchronize two reactive words together. So we would like to set the other signal when one signal changed. But as it said in the documentation, it's not what the effects were intended to. They were rather created to synchronize not reactive word with reactive word. So how we exactly should use the effects and how we should synchronize to reactive properties where needed. So let's take a look at the simple example of select component. This select component accepts as an input options and have an index signal which tracking currently selected index. And right now, whenever options change, we probably would like to reset our index again to be -1. So what we can do, we can use effect, call their options just to register as a consumer of the options. And whenever options change, our effect will be triggered and we set index to -1. As you noticed, maybe we need to strictly say that we are allowing signal writes in scope of these effects, otherwise it will throw error and it will not work properly. But as I said, it's not the very good use case for the effects, because as you see, we use options here only to register as a consumer. We don't need information like what are the new options, what has changed. We only need to know that options has changed and we need to invoke it. So we just register as a consumer, but we don't do anything with this value. So what are the alternatives? Okay, so maybe we can create the computed, which will listen for the options, and whenever this computed is triggered, it will return the computed of options and signal of index containing -1, and that might be the solution. But again, I don't think it's being intuitive for anyone, and also it's something tricky. You need to think for the longer while how to just set up and handle this scenario. And there is the place where Angular team come to us with the linked signal. And linked signal is kind of the signal, very similar to the computed, which accepts two parameters. The first one is the source, and the source is the signal it's going to depend on. And the second parameter is the computation function, which will be invoked whenever this source signal change. And it sounds very familiar to the computed, because it's simply maybe do the same, but there is like another set of options that we can modify it. So it have the set function, which we can utilize to update our computed property. And right now, having this scenario, whenever the options change, the computation will be triggered. It will set the index to be -1, but when we change the index manually, we can update it as it will be writable signal. How it affects the change detection. So as it was said today, we have like mostly two famous strategies. The default one, which is checking everything. We have the on-push change strategy, which checks the entire path from the child to the root or from the root to the child, what has changed. And in the perfect scenario, we have the signal-based change detection, which checks only this component in scope of which the signal changed. And it's differentiated from the Zone.js, which was event-based. So Angular with Zone.js never know what exactly has changed. He knows that something has changed, but he don't know exactly what. He know where a little bit, but don't know whether he need to check other components or not. Here, based on the signal, as we know, the views might be registered as a consumer. So he exactly know which signal changed and which consumers needs to be updated. He don't need to go throughout the entire tree to verify who needs to be changed. And even in the better scenario where we'll be really fully based, it's not yet implemented. I know it was discussed to that. So in majority of cases, it's not working yet like that, but it will do some selective updates. So if I will zoom this small component at the very bottom, it will be divided into smaller views. And not the entire view of the component will be change detected, but only the smaller slice of it. So it's even more precise and performant than it was in the past. So how it simplifies components. So starting with inputs, we don't need decorators anymore. Right now we have the input function, which will automatically create for us signals. What might be confusing in compared to the decorator-based inputs, we cannot update this input from child component, and it's tricky because we get used to that, and even Angular material nowadays is I don't know, but was decorator-based because they have been modifying manually, for example, disabled property. If the disabled will be signal-based input, they will not be able to update it. An alternative is the model input, which is doing two-way data binding. But again, the two-way data binding means that we are just modifying it in scope of the child, but also in the parent. So again, it's different experience than it was in the decorator base because you have been modifying only in the child. We can achieve exactly same with the model because if you notice right now at the left side, I provide the count input as a reference to my signal. But if I provide it as a value, then model do not do two-way data binding right now. So I can write to this input, but it will not bind data back to the parent. So it will behave like an old-fashioned input with decorators. Outputs undergo some changes, but it's only alignment in the syntax. They have nothing to do with the signals. View children. Here, similarly, we don't need the decorators anymore. Right now, we have the functions, view children, view child, who creates the signals from the DOM reference for us, from the component, depends what we refer to, and we can utilize it as a normal signals. There are two new hooks introduced. One is the after render, and it's pretty tricky because we call them hooks, but for example, after render will be triggered whenever something changes in the DOM structure, and it's not strictly correlated with the component you are using it within, yeah? So it's not like the previous hooks that they depend strongly with your component, whether it was init, was checked, and so on. This will be triggered whenever something changes in the DOM. There is another one, which is after next render, and it will be triggered only once whenever your component finishes rendering, and it's just the very good place to initialize some kind of the third-party libraries, like, for example, charts, because we know it's already initialized, so rendered, we can just use the charts. Okay, so how it's evolved the state management of Angular. First of all, let's look how we have been doing it in the simplest possible scenario in the past. We have been declaring the service, in scope of which we had the behavior subject. We have been exposing it as an observable. We have some method to fetch the data and set this observable. Then this observable was consumed in scope of our component, and using the async or subscribe, we have been just getting the data. So how we can synchronize this kind of the behavior using the signals? We probably will think again, okay, let's just use effect. And right now, whenever the product ID change, I want to fetch the products and set them. But we already know that is bad practice and not recommended way of usage for effects. So what we can do? And here in the version 19, Angular team will introduce resource and Rx resource. And it's another primitive which helps us with fetching the data. It has also a very simple API. It accepts two parameters. One of them is loader function. And what is pretty important here, because we might not get used to this in Angular, the loader function needs to return promise. We mostly, when we think about fetching data in Angular, we always see this in case of the observables. But here we see it will be the promise. Rx Angular is to return observable. So we have two different primitives, Rx resource and resource. And what it returns for us, it returns the value of the resource, it returns its status of the loader function, and whether there was error or not. And it's being invoked immediately when it's initialized. So let's see what our effect will console log. Initially, it will log for us value as an undefined. It will return us status as loading and error as undefined. And when the promise resolve, we'll already have their value as an ID, my product, and so on. Status will be resolved because promise has been resolved, and then there is no error. Okay, so how to make it listen for changes of the signal and invoke? We might think that maybe we should put the signal in scope of the loader function, but it's not like that. It will not work. Loader function is untracked, and it's not tracking usage of the signals in scope of this function. what we need to do, we need to define another property, which is request. And request accept the reference to the signal based on which it's need to invoke. And then in scope of the loader function, it's accessible for us under the request property. Okay, so if you would like to get like switch map experience, you will need to define abort signal. Otherwise, it will behave like an exhaust map. So choose currently pending request as a more priority one. If you want like to switch map experience, you need to define and use this abort signal. Okay, it also have two functions. The first one is refresh, to just invoke this without the need of changing the signal and so on. You want to re-invoke it with those parameters which were recently defined. And also what you can do, you can update it manually. So it's don't have to be done via the request, but it's also contain the update method. And what is the methodology here? If there is pending request and you make an update, the pending request will be cancelled and the value from the update will be respected. And if we take a look and we define a bunch of kind of the resources in scope of our components, it can grow pretty fast. And also what as an Angular community, I believe we work over the years to just not overcomplicate the components, don't put too much logic there, and don't make for sure requests and subscribe to this request in scope of the component. So if we take a look at this kind of the scenario when we maybe define some responsibilities of the things in our architecture, we might have the feature, UI, and data access. We don't want UI to deal with the data access. We probably would like to keep it and expose resource as a part of the service or keep it somewhere outside of the component. And I think there will be two things to do that. And both of them will enforce us to, wrap the resource with the arrow function. And this way we can put the resource in scope of our data service, or we can define it as an injectable function, which we can then utilize in scope of our component. And with applying these two approaches, we can slightly move the resource out of the component to just do not make component too big with too much of the responsibilities, and utilize this kind of the approaches in scope of our component, which will look more or less like that. So we will inject the product resource or just utilize it directly from the service. And there is comparison like how it will looks like. Okay, so as I said, signals affecting really a lot of things, and not only the Angular itself, but also the kind of the libraries around the Angular. And one thing which strongly evolved with Angular is NGRX store. Initially, we had this Redux-based store, then they introduced component store. It was very close with discussions in the community that we need more narrow component-based state management. We don't always need the global one. It wasn't so much successful, so right now they introduced its successor, which is Signal Store. And the Signal Store in NGRX is more like building something from the code, like from the Lego blocks, because you utilize defined by them blocks. One of them is with state, which is the function to define your state, which will be the signal. Then you have the methods, which you can define in scope of your store. Then you have computed, which will be derived computed properties from your state, simply like computed. And you have also with hooks, there are two hooks on init and on destroy, very familiar for us as we use ng on init and ng on destroy in Angular. There is even more helpers like with entities and so on, but these, in my opinion, are the core one. And we can utilize them this way. So we define signal store using the signal store function. We provide with state, where we define the structure of our state. Everything we define in scope of with state will be the signal. Then we define methods like add book, fetch book, update book, whatever we want, and then create computed properties like books we can rent and so on from our state. And this way created state we can utilize in our component by defining it in scope of the providers and injecting in scope of component. So what about the forms? And 2 days ago, there was a conference called NG Poland. There was Angular 3 of guys from Angular core team, and they announced that they are already working on the forms to be signal-based. So this is exactly screenshot from the presentation they gave yesterday, and more or less we can expect that the signal-based form will look this way, that we will have the access to the field. We will define it using the signal form, providing the structure of data. And I don't know how it will work exactly, but more or less we can expect this kind of the API. So to summarize, we saw that the signal goes already over the entire Angular, starting from simple primitives to the change detection, forms, and fetching the data. And we can expect that in the few releases, maybe one more or two, Angular will be fully based on the signals. Thank you. She didn't expect me to finish.
After a great run, I'm here with a question. So, the talk was very interesting, but how did Real Madrid's last match in the Champions League go?
It's pain. Yeah, the last two games were pretty tough, would say, yeah, with Barcelona and Milan, but we'll come back stronger. And guys, I hope we'll celebrate another Champions League this year, so be patient. The 16th one, by the way.
And then the source API looks a little bit like mini services providing state info. What is the main difference between them?
Between what?
Mini services providing state info.
I don't know exactly, to be honest, how to answer this. I don't have like experience with this kind of the services. So
I don't know if you...
Tough to elaborate. If someone wants to discuss it maybe deeper, what you mean, then I am for sure open.
Don't see any hands.
So. Yeah, but we can refer to resource as the resource from the solid. So it's very, very similar. So if you would like to read some kind of the documentation or something what's provide you with knowledge behind this primitive, the solid.js is the framework who already have exactly same, maybe not exactly same, but this API is inspired by solid. We can say this way.
Perfect. And nothing more. So okay. Thank you very much, Mateusz. Again.